Hey guys, welcome back. We are taking a look here a little bit deeper at Chapter 5 when we're looking at 5.2 and this idea of what are called logarithmic functions. All right, so start off with a pretty easy true or false question. All right, every exponential function is a one-to-one function. Okay, well, if we think about this, an exponential function we just saw looks like one of two ways. Does something like this. Okay. Or maybe it does something like this, okay? But either way, it is a one-to-one function because it passes not only, first of all, it's a function because it passes the vertical line test, but each of these pass the horizontal line test, all right? So they are one-to-one, all right? So what that means is we can find the inverse of an exponential function. We can take an exponential function and run it backwards. Okay, and that's what that's where logarithmic functions come into play. All right, so a logarithmic function is basically the inverse, the backwards running of an exponential function. Okay, and it says if we're talking about positive x's and positive b's and b not equal to 1, because again up here 1 to any power is kind of boring. It's always 1. So positive x's and positive b's. And every positive b except for 0. This logarithmic function with base b, all right, is noted like this: y equals the log base b of x. Okay, is identical to, okay, or is the same thing as x equals b to the y power. Okay. Probably equals is not the right symbol there. We'd say if and only if. Okay, so this equation is true if and only if this equation is true. All right. So in other words, if I have an exponential equation, x equals b to the y power, I can rewrite that as y equals log base b of x. Okay. Now we're going to see where this applies, and right now it might not, might be a little bit confusing. But basically, what this allows us to do is take an exponential and write it as a logarithmic function, and that's going to have some applications later, and hopefully we'll see that here before too long. Okay. All right. So one of the first things then, since you guys are just being introduced to this, one of the things that I want you to work on and that your homework is going to deal with is just changing from logarithmic to exponential. All right. So, and again, there's nothing to solve here. All right. There's no variable here. This is just an equation written in exponential form. So we want to write this. This is written in logarithmic form. We want to write this in exponential form. So again, it's important, I think, to say log base 3, because that kind of tells me that my base in my exponential is 3, and then I just automatically switch these two things. Okay, so to say that 3 squared equals 9, just another way to say that is log base 3 of 9 equals 2. It's almost like translating a foreign language, I guess. So this is exponential form, this is logarithmic form. But again, catching that this is called a base and this is also called a base, I think will help you, all right? Because if this is a base, then I have to write that as a base. So for example, if this is a base, log base 16, I'm going to put that as the base, and then I just automatically switch those two numbers. Okay, and 16 to the 1/2 power is 4. Okay. Same thing here, log base 2 of 1/8 equals -3. So I write that as my base. I put -3 now as my exponent. And I get I've got 2 to the -3rd equals 1/8. Which we know because 2 to the 3rd is 8, so 2 to the -3rd just switches those two, so that's 1/8. So one of the things you're going to be asked to do tonight, there's no solving or anything. We're not finding any variables here. We're just translating, again, just like with beginning Spanish or beginning Latin, just being able to go back and forth. Given one form, can you write it in the other form? And this is going the opposite way, all right? Changing from exponential form to logarithmic form, all right? So here I see my base is 9, so it's log base 9, and then I switch these two. Log base 9 of 81 equals 2. And again, I probably should have started by writing this as 9 squared equals 81. That way you can see the actual switching there. I'm actually going to go down here to this one, and I'm going to write it with my exponent on the left-hand side. I think that'll be easier for you to see. So again, this is a base, so it's log base 7, and then I switch these two of 1/49th equals -2. Okay. Now this one, again, a little bit different because you say, wait a minute, where's the exponent? Well, I can write 144, the square root of 144 as 144 to the 1/2 power. Okay, so I can write this as 144 to the 1/2 power equals 12. So again, there's my base. So log base 144. And then I switch these two of 12 equals 1/2. The exponent in my exponential form becomes the answer in my logarithmic form. So again, this is written, exponent's already on the left-hand side. My y is my base. This is just kind of the general form. So log base y, and the exponent in my exponential form becomes the answer in my logarithmic form. So again, one of the things that you're going to be working on in your homework is just going back and forth here between these two. If I give it to you in logarithmic form, can you write it in exponential form, and vice versa? If I give it to you in exponential form, can you write it in logarithmic form? And now there'll be some things to evaluate. All right. So for example, if I say evaluate these, so log base 2 of 1/2 equals, let's call it x. You can call it whatever variable you want. So, I don't know what that is. I don't understand logarithmic, but maybe if I translate it to exponential, so get log base 2, so 2, and then I switch these two. Remember, the answer in my logarithmic form becomes the exponent here. So 2 to what power equals 1/2? Well, all I've done is switch it over. So now we are actually solving these things. We know that x is -1. Same thing here. I want to know log base 100 of 10 equals what? Let me zoom in here a little bit. Okay, so this is my base. So I write that as the base in my exponential. The answer to my logarithmic becomes the exponent in my exponential form. So 100 to what power equals 10? Well, what do I need to do to 100 to get 10? I need to do the square root. I know I can recognize, hey, wait a minute, the square root of 100 equals 10. So what exponent does the square root? 1/2. And then finally, here I do log base 10. Log base 10 of 1,000 equals what? Equals x. So 10 to what power equals 1,000? There, x equals 3. Okay. So again, once you catch on how to write logarithmic as exponentials, we can start to evaluate these. Now, two different kind of logarithms that are going to come up quite a bit are logarithms that have base 10. These are called common logs or common logarithmic functions, and logarithms that are base e. We talked a little bit earlier about that number e, irrational number e, about 2.72. These are called natural logarithmics, and these are written, instead of writing log base e, they write it as ln. That's a little l. All right. So when you see ln, that's the same thing as log base e. So we can use these. We can use your calculator to evaluate these. So if, for example, if you don't see a base, it's assumed to be a 10. All right. And that's what your calculator does. All right. Your calculator, when you use your graphing calculator, when you see this log button, it's doing log base 10. So to use your calculator to evaluate the log of 100, I simply type in log and 100, and I get 2. Okay, the log of 100 is 2, which makes sense because if that's base 10, really what this is saying is 10 to the second power equals 100. Now, log base 233, really what I'm saying is 10 to what power equals 233? And it ain't nothing pretty, all right? So, but my calculator can do it. I can just do the log of 233, and it's approximately 2.37. If I try to do the log of negative 2, all right? So let's do log of negative 2. And it gave me an error. Why did it do that? Well, basically, we're asking 10 to what power equals negative 2. And we've seen, you can never do 10 to any power and ever get a negative. Because remember, even if we start doing negative exponents here, this thing has that asymptote of the x-axis. It's going to get closer and closer and closer to 0, but never actually go negative. Matter of fact, if we just quit, if I tried to do the log of 0, it also gives me an error because 10 to any power will never be 0 or a negative. So not all logarithms can be evaluated. Log of 1, all right, I simply hit log of 1, and that's 0, all right? So log of 1 is 0. And again, that makes sense because, again, we're asking 10 to what power would equal 1, and anything to the 0 power equals 1. Natural logarithm, they've actually got a button for that. And so, again, what they're asking here is e to what power equals 415. I don't know, but thankfully the calculator does. So I do natural logarithm of 415, and again, I get about 6 3/3. Okay, natural log of negative 2. What do you think is going to happen here? Yep, you're right. I can't do it because, again, e to any power equaling a negative. All right, it does not exist. All right. Yeah, so probably that's what we should put there. DNE, the natural logarithm, or undefined, something like that. Okay. All right. So just this brief introduction here to logarithmic functions, being able to go from a logarithmic to an exponential equation, being able to go from an exponential equation to these things called logarithms. That'll help you evaluate. But again, there are a couple out there, base 10 and the base E, the natural logarithm, that your calculators will do for you. All right. So go ahead and take a look at these problems. If you have any questions, shoot them out through Remind or get a hold of me, and I'll be happy to cover those with you. All right. Take care, guys.